20,000 Varuna is a large trans-Neptunian object, TNO, in the Kuiper Belt, discovered on November 28, 2000 by astronomer Robert Macmillan using the Spacewatch telescope. It is considered a possible dwarf planet. Varuna orbits the Sun at an average distance of about 43 astronomical units AU, with a moderately inclined and nearly circular orbit. It completes one orbit roughly every 279 years. The object has an elongated, ellipsoidal shape, likely due to its rapid rotation of approximately 6.34 hours, which may have been caused by past collisions. Its surface is moderately red, indicating the presence of complex organic compounds, and contains exposed water ice. Varuna is named after the ancient Hindu god of the sky and oceans. While no moons have been directly observed, light curve analyses suggest a possible small satellite might be orbiting it. Estimates of its size vary, with some measurements suggesting a mean diameter around 400 to 430 miles, 650 to 700 kilometers, though earlier estimates were higher. Its low density, 0.99 gcm to the power of 3, raises questions about whether it is in hydrostatic equilibrium, a key criterion for dwarf planet status. Size comparison. Having an estimated diameter of 415 mi/668 kilometers, making it significantly smaller than Pluto and other major dwarf planets. Pluto, 1,476 mi/2,376 kilometers in diameter. Haumea, 1,014 mi/1,632 kilometers, average, elongated shape. Varuna, 415 mi/668 kilometers. Varuna is roughly 1/4 the size of Pluto and about half the size of Haumea. While larger than many trans-Neptunian objects, it is much smaller than the primary dwarf planets like Eris, Pluto, Makemake, and Haumea. Time. This candidate takes approximately 279.21 years, 101,980 days, to complete one orbit around the Sun. Some sources estimate it as 283.20 years, reflecting slight variations in measurement. Rotation period. Varuna has a rapid rotation, completing one spin every 6.34 hours. This fast rotation contributes to its elongated, ellipsoidal shape. The candidate has a nearly circular orbit with low eccentricity, 0.051 to 0.054, at an average distance, semi-major axis, of 42.7 to 43.1 AU from the Sun. It orbits between 40.8 AU, perihelion, and 45.4 AU, aphelion, placing it in the classical Kuiper belt. Its orbital inclination is 17.2 degrees, classifying it as a dynamically hot classical KBO. Varuna is not in resonance with Neptune, avoids significant gravitational perturbations, distinguishing it as a stable, non-resonant trans-Neptunian object. Discovery. Varuna was discovered on November 28, 2000 by American astronomer Robert Macmillan using the Spacewatch 0.9-meter telescope at Kitt Peak National Observatory in Arizona. It was identified through manual analysis of survey images using the blinking technique, as automated software initially missed it. The discovery was formally announced in a Minor Planet Electronic Circular on December 1, 2000, with the provisional designation 2000 WR106. Precovery Images later extended its observation arc back to 1954. Planetary structure. Varuna has a low bulk density, 0.99 gcm to the power of 3, suggesting a porous internal structure composed of a nearly equal mix of water, ice, and rock. It likely has a granular interior formed by fractures from past collisions, which may also explain its rapid rotation. But it is not fully differentiated. Its rocky interior hasn't fully settled due to insufficient internal heating since formation. This partial differentiation and high porosity mean it may not be in hydrostatic equilibrium, a key criterion for dwarf planet status. Its surface is moderately red, composed of 25% water ice, 35% complex organics, 25% amorphous silicates, and 15% amorphous carbon. As of now, no moons or rings have been definitively confirmed around Varuna. While some light curve analyses suggest the possibility of a small satellite, Direct observations have not detected any moons. Similarly, there is no evidence of rings surrounding Varuna, unlike some other trans-Neptunian objects such as Haumea. Early history formation. Varuna formed in the Kuiper Belt over 4 billion years ago, likely through the gradual accretion of ice and rock in the early solar system. Its rapid rotation and elongated shape suggest it may have experienced a significant collision in its past, which could have spun it up and fractured its interior, contributing to its high porosity and low density. As a classical trans-Neptunian object, it has remained in a stable, non-resonant orbit, avoiding major gravitational disturbances from Neptune, preserving clues about the primordial outer solar system.